So, today we are going to solve this integral, and the integral is e raised to power x into cos of x, and we have to integrate this with respect to x. So, as we can see that we have a product of two functions e to the x and cos x, and we want to integrate it. So, whenever there is a product, we use integration by parts, and the formula for integration by parts is integral of u dv is equal to uv minus integral of v du. Our question is in terms of x, not u and v, so we have to let u and dv in order to use integration by parts to solve this. In this particular question, it doesn't matter whether we take e to the x as u or cos x as u, because normally we consider that function as dv by dx, which we can easily integrate. In this particular case, we can easily integrate cos x or e to the x. If there was cos inverse of x, we would have we would have let that cos inverse of x as u and not as dv by dx, because to integrate cos inverse of x, that would have been difficult. But in this particular case, no inverses are present, so we can either take e to the x as dv by dx or cos x as dv by dx. So I am considering cos x as u, and I am considering e to the x as dv by dx. And why do we consider dv by dx, not dv? Because dx is already present here. Dx is already present here, and we consider e to the x as dv by dx, so that dx and dx cancel out and we are left with dv. So cos x will be u, and dv by dx will be e to the x. Cos x will be u, and e to the x will be dv by dx. So dx and dx will be cancel out, and we will be left with u and dv. So that's why we consider ex as dv by dx. Now we will apply the formula. Formula is uv. First we need to have some requirements, or we need to have some things which are necessary to apply this formula, and those things are du by dx and v. So we have considered cos x as u. Du by dx will be simply the derivative of this u with respect to x, and the derivative of cos x is minus sine of x, and dv by dx is e raised to power x, and we need v. So in order to get v, we have to integrate this dv by dx with respect to x, and the integration of e raised to power x is e raised to power x. So we needed v, which we have now, and we needed du, and we can find du from du by dx by simply cross multiplying. So du will be minus sine x dx, because du by dx is equal to minus sine x. So this integral is equal to, and we have called this integral I, and the formula is uv, which is u is cos x and v is e to the x. So it will become e to the x cos x minus v du. V is e to the x and du is minus sin x dx. So this will become e to the x cos x plus this minus, and this minus will multiply to give us plus. So e to the x sin x dx. So we have this integral. We need to find the value of this integral to get the original integral. So again, we can have either e to the x as u or e to the x as dv by dx. It doesn't matter, because both of these functions can be easily integrated. Normally finding the derivative is easier as compared to finding the integral. So in this particular case we can take either as u. So we have taken sin x as u and we have taken dv by dx as ex. The derivative of sin x is cos x, and integral of e to the x is e to the x. So we will apply the formula again. So this will become e to the x cos x plus uv, which is e to the x sin x, minus integral of v du, which is e to the x into du, which is cos x dx. So this was our original integral, and we have called it I. So we can replace this integral by I. So I is equal to e to the x cos x plus e to the x sin x minus I. So we are interested in I. So we will move this negative I to the left side. So I plus I is equal to e to the x cos x plus e to the x sin x. 2i is equal to e to the x cos x plus e to the x sin x, and we are interested in I. So this 2 will be divided on the right side because it is being multiplied on the left hand side. So I is equal to e to the x cos x plus e to the x sin x over 2 plus c. This will be the value of our integral. So here I have taken e to the x as u and dv by dx as cos x, and the reverse of which I did before. So I'm just showing you that the result will be same. I is equal to e to the x sin x plus e to the x cos x over 2 plus c. And what does the answer mean when we find the integral of something? So the answer means that that particular answer, the derivative of that expression is the expression which we were integrating. So this was our answer, 1 by 2 e to the x cos x plus sin x, and we just need to differentiate it to uh, get the expression which we were integrating, to check whether this is the correct answer or not. So we will differentiate this with respect to x, and this is a product. So in order to find the derivative of this, we need to apply the product rule. 1 by 2 as it is, the derivative of first function as it is, the derivative of second function cos x has derivative minus sin x, and sin x has derivative cos x, plus second function as it is cos x plus sin x, and the derivative of first function e to the x. And we just need to multiply this and add this. So these two terms cancel out and this 2 also cancels out. So we are left with the original function which we were integrating, e to the x cos x. So this is indeed our solution, because this has the derivative equal to our function which we were integrating.